PSA, don't turn off File Vault on your APFS volume because then you can't boot anymore. But I've recovered my Keynote deck, so that's good. So this is Osquery and Streamalert. So hello. If you don't know me, I'm Sam. I'm a security engineer at Airbnb. And I don't know why I decided to do this talk exactly. It's going to be a few talks in one, I think. But why this talk? Because imaging isn't dead yet. So here's quick talk number one. Quick talk number one is about Osquery. You've probably heard about it by now. But there have been some changes to it over the last year that have been really good. But I just want to do a quick refresh. Henry went over it. I think a couple other people have mentioned it over the last couple days. But if you don't know what it is a tool for auditing machines and gathering information about them. So like at the most basic level, you might have a bunch of queries that look like this. It's all SQL driven, so you can select information and get one or more results about a machine. I think when Osquery is shown off, it's mostly through this interactive interface. But if you were to move along, like beyond that, like you want to schedule queries to run at some interval. So you would use packs for this. There's a lot of packs that it comes with, which come with a lot of really good queries. So this one is the OS10 attacks one, which contains a lot of indicators for common malware. So these queries run on some schedule, like once an hour. And if there's a change to the results, then that would get logged somewhere and sent somewhere. Here's another one. This is the incident response one it comes with, which contains more common information, which would change more often, like launch daemons and cron tab if you use cron on OS 10 for some reason. But something new. These queries aren't going to return a lot of data very often. Like on an average machine with the default packs enabled, you're probably going to get like maybe 50 to 100 results per day. But let's turn it up to 11. So there's a new-ish feature in Osquery, which is the ASL table. So that's the Apple syslog table. And this can get all of the log entries from ASL. And it's treated like SQL. So here I'm selecting just the time and the message where the sender is monkey. So like for this to work, you would have to configure monkey to send a syslog, but that's really easy. It's just a flag. But like most other applications, you already log things into syslog. Now, most queries that you might see in Osquery are just like select star from a table. If you do select star from a table in ASL, you're going to get probably 300,000 results at least. And that will melt things. So you might want to craft your query a little bit better. But like in truth, even if you just added this query because you wanted to see the logs for monkey, monkey's logs are probably going to be 1,000 lines a day. That's going to be like 20 times what you would get out of the box. So what do we do with all that data? So traditionally, like if you were using Osquery like 2 years ago, you would be using it with something like Splunk or Sumo Logic. You would have Osquery log its results into a file, and then you'd have a Splunk or Sumo Logic agent installed on that box to come and pick up those log files. Now this works, but it's not amazing because you have to install a Splunk or Sumo Logic agent on your machine. And I've done this before. They're not great. They're really designed for servers and traditionally have like a significant resource use, or they need Java or some other mess to run. And the other problem with using these agents to collect logs off of your machine is that they want to send their data to themselves. So if you collect data with Splunk, it goes to Splunk, and Splunk is where that data lives forever. It's really hard to practically get that data out of Splunk and not have it be its like forever home. It's also incredibly expensive to store that data in Splunk forever. And it's probably not even what you really need. It gives you live access to search this data basically forever, but you probably don't really need to do that. So there's newer alternatives with TLS, the TLS plugin for Osquery. So you might have heard about this thing called Zentrol. It's pretty cool, but I don't know how to use it. So I was listening, but when I wrote this, like half an hour ago, I didn't know how to use Zentrol yet. So, yeah. So, like that's what Osquery kind of looks like today. There's other TLS servers that can receive data. You can even get, if you configure it properly, you can get Osquery to send its results directly into Splunk or Sumo Logic by configuring like a receiver URL, but you've solved half of your problem in that you don't have to install their agent anymore, but they still own your data forever, and it's incredibly expensive. So there's a better option. So we're going to move on to quick talk number 2, which is Amazon Kinesis. So Amazon Kinesis is one thing. It's really two things, but with different flavors under the same name. So first you have Kinesis Firehose, and then you have Kinesis Streams. Kinesis Streams was the original Kinesis, but it's been renamed Kinesis Streams once Firehose was introduced. And we're going to go through both of those. So the first one, Kinesis Firehose, is designed to take data coming in to a URL basically, and then just like take this huge amount of data and send it somewhere. Most of the time that would be just writing it out into S3, but it could also go into like the Redshift database. But S3 is probably the most common for this. You can send it into Elasticsearch as well, but here we're going to talk about S3. So who wants to drink from the fire hose? Oh, it didn't work. That's too bad. Did it work? No. There you go. Who wants to drink from the fire hose? So if we combine Osquery and Kinesis Firehose, we can end up with something pretty good. So I've done an amazing job photoshopping this. But Osquery now has Kinesis support built in. It's just a small modification on the TLS support because Kinesis wants slightly differently formatted things. But here what you could do is have Osquery send its results to Firehose. Firehose would write this data out to S3, and then Splunk or Sumo Logic can come by and like basically everything supports this and read that data from S3. So with this method, it's going to take a little bit longer for the data to be searchable in Splunk or Sumo Logic, like maybe by a couple of minutes. But you can have your long-term storage in S3. You can set up rules to, send that data to Glacier after a month. So you have that data forever, and you can get back to it if you need to, but you don't have to pay like millions of dollars to keep years of data live, searchable. And you can set up your Splunk or Sumo Logic instance to only keep data for a month or a week or whatever is actually useful to you. And these products do support reloading data. So if you had like an incident or something and you needed to read this data, you can go back and have your tool do that. So this is a new feature as of, I believe, Osquery like 1.8, which came out maybe 6 to 8 months ago, or maybe a bit longer than that. I don't know. It was in the fall sometime. So that's Osquery and Kinesis Firehose. So the other side of Kinesis is Kinesis Streams. Now, I didn't make this. I stole this from the Amazon site. They were really good at making diagrams. But what Kinesis Streams does is gets the same kind of data coming in from Osquery. So it's still JSON. It's a JSON blob with the result from each query. But then it's going to actively do something with it. So Wade talked about Lambda a little bit earlier. But Streams is intended to be used with Lambda, I think, is like the biggest use case. You can do some other things with it. But basically, the data will come in, sit on the stream, and then Lambda will come and pick up each object from there and do something with it. But it's not going to sit on that stream for very long, like maybe a few seconds, but it's going to get discarded in the end. Firehose is meant to send something somewhere where it's going to be long-lived. Streams, the data is only going to exist for a very short amount of time. And so you're going to write a Lambda function to parse that data. So a little bit about Lambda. Wade already talked about this, but basically you write whatever you want. You want to have it be fairly optimized. So you're probably going to be hitting Lambda like millions of times a month, or billions, or even trillions if you enable ASL. So it's going to keep the scripts loaded and warm. So like if you're importing the same library a million times, it's not going to it's going to keep that library imported in memory. It's not going to take milliseconds to load that every single time. But it supports not a wide range of languages, but a wide enough range of languages that everybody should be comfortable with one of them. The best part about Lambda is that it supports Python 2.7. So I would hope that everyone in this room is familiar with that by now. So we can combine Lambda with Osquery and Kinesis Streams. And so that leads us to quick talk number 3. And that's Streamalert. So Streamalert is an open source project that has been developed by Airbnb's security team to run in Lambda and parse data that's coming in. So basically, having rules that can parse data that is fed into it and then act upon it if something matches. So it's all up on GitHub, and this is a little bit about how it works. So I'm just talking today about Osquery as an input, but it can take inputs from a lot of other things and does so very efficiently. So it can receive billions of Osquery results every day. Lambda is super efficient. You don't have to run any servers for it. And you can write rules to determine if you want to do something with this data. Like 99.9 repeating % of these results are just going to get discarded because they're normal things that you were expecting to happen. The normal things that you were expecting to happen, you're probably going to like graph those over time with your data that you're sending to like Sumo Logic or Splunk. But this is meant for those outliers, those unique things that you actually want to respond to and do something with. So if you had like basically anything match in the malware pack from Osquery, you probably want to do something with that. That's going to be an outlier. And so Streamalert can talk to any API. It comes with a few things built in, which are probably very common, like PagerDuty or Slack. It can write things out to S3, which you probably want to do just to like keep track of everything that was ever like alerted. But yeah, it can talk to anything. So if we look at the next slide, this is what a rule looks like in Osquery. So it's just simple Python. This is one of the sample rules that is included. And what it would do is look for someone sudoing on a production server. So this runs on, Osquery runs on Linux and Windows and all the different things. But if something matches one of the results that you have, then this one would send something to PagerDuty and Slack. So someone's going to get a page then. And this is all on the Streamalert page. So there's lots of examples. It's simple Python. So that's how Streamalert works. And when it all gets put together, you end up with another really, I promise I didn't use MS Paint for this. So you end up with Osquery also sending its data to Kinesis streams, Streamalert's running in Lambda, taking the results off the stream, acting based upon them, and then sending a very small amount of results on to a notification service like PagerDuty or Slack or whatever you need. So that's Streamalert. It's really easy to implement. As Wade showed earlier, deploying Lambda functions is like the simplest thing ever. This is really great because it scales automatically. We don't have to run any servers for it. Our volumes do come in waves throughout the day. We have a very strong peak at like 3 p.m. Pacific, but then 12 hours after that, our volumes are incredibly low because all of our machines are offline. And this just automatically scales up and down throughout the day. If there's a bunch of updates that go out or a large amount of logs, we don't have to worry about things melting down. It's just going to be a little bit more data. And honestly, if you write your Lambda functions efficiently, like one Lambda function is going to be as cheap to run as like one small EC2 instance. So it's not going to cost a lot to run something like this. So that's all I have, but if you have questions or statements, questions and statements, yeah, that's it. No questions or statements?
Thank you, Sam.
Thank you.
Questions? Mark?
Thanks, Sam. So are you using this in a production environment right now, or is this kind of a proof of concept?
We do use this in production. I mean, I've got thousands of machines sending probably 10,000 results every day or more. So we do actively use the ASL table. I do carve out things that I know that I don't want. So when we were first deploying this, it was like, how do I want to craft my SQL query for the ASL table? I could be like, I want all of these things, but then I knew that I was going to like miss things if there's ever an incident or something later that we need to go back and see what happened. There would be things carved out. So I select everything except like basically everything from the Windows server because it's very spammy, and like some other things that are just like repeated all day long, like parental controls D. I don't log those because that would like triple our output. But yeah, it's used in production, no problems.
So Streamalert you're using strictly for incidents that require notification. Are you still using Splunk or Sumo Logic for longer term data insight?
Yes. So we do use both of these. So it's like, I guess the best way to put it is like, Streamalert should hit a very small amount of things. And then maybe if you hit something in Streamalert, you would go back into your other tool to search for other instances of that or search for similar things to that or see what else that machine was doing at the same time. It's like you have an indicator and then you can go search for more evidence. But like S3 is so cheap to store this data in that like there's no reason not to. If you have like the 7-year retention or the forever retention requirements, it's not gonna give you like a $10 million invoice from like Splunk, because that's what does happen there. And it also keeps your queries in those tools more performant, because when you have 7 years of data in there, you run one query and it's going to take an hour to potentially find everything. So you can keep a small amount of data there and just load in what you potentially want later.
Questions for Sam? Questions.
Have you found ULS versus ASL? Any differences there? And are you capturing anything from ULS, or are you just getting things from ASL?
I have a statement about that.
So
I'm serious. Supposedly, and this is not because people can just rub Python on it and all of a sudden it does magic tricks, but I've heard that ASL-ish ways to pull out from unified logging has been deployed at certain organizations that Edgar works for.
yes. So
Which sounds really awesome, and yet, and you can still use the new way of using predicates against it, but you can still therefore get it to stream out what you want from unified logging.
yeah, so I think there's some desire and need for Osquery to be adapted to work with unified logging. ASL covers most things at this point, and yes, it is deprecated. So like if you build Osquery and target the 1012 SDK, then ASL doesn't work anymore. But I would say even though you miss things, I would still rather have that than have to install like this giant package for gathering logs, whether that's like a Splunk forwarder and all that stuff. Yeah. There's work to be done, certainly, but it's a start.
That's a lead on to a question I have about how are you avoiding missing logs? So someone's offline, they're on a flight, they're on a train, their machine's generating logs. How do you store and ship those later, or do you just not care?
So this was definitely something that I considered when I was doing this. So there's kind of two ways. So if your computer's open and it's running, so Osquery is running, but you don't have an internet connection, so Osquery will cache results for, I believe the default is 1 day if it can't send them to the server. So that's half of it. But then the other half is if Osquery is not running, you don't want to miss things, right? So when you do your query, what I do is I run that query every few minutes, but the query searches for results over like the past hour. So, if Osquery hasn't run, it should overlap. Like I could miss some things in some cases, but if you're on the train, and then it's going to cache them until the next time you're online. And if Osquery dies, then it'll, like if it's restarting or something, then you should be okay too. That's how I solved that problem. But including that time limit inside of your query, if you're using the ASL table, is crucial because if you did just like select star, or not even like select star, but like you had all these extra things, it's still going to return like, many, many, many thousands of results. It's going to use a bunch of memory, and then it's just going to be bad. But this way, it's returning a small amount of objects, and then it just returns a new one. So you could make it more efficient, but like if you run the query every 10 minutes and search for the last hour of logs, then you're probably going to be okay.
Thank you.